Hi everyone. So in this video I'll try to address one of the very common problem which is asked in interviews, and this problem is of concurrency issues, right? So I have done a few implementation as well for concurrency issues. So I will try to look at these implementations as well. But before that, let's try to understand what is the problem. So let's say we have a application like Book My Show or a car rental system, or you can say a hotel reservation system, or any sort of booking system where user can come and book a event. Okay. Now what happens in these scenarios that there can be a possibility that there is an instance where more than one user are trying to book for the same event, and as a good application, as an as a good user experience also, the our application should not be able to do double bookings, right? I mean, two people trying to go to the same event, trying to sit on the same seat, that's not possible, right? So that's why we need to deal with these situations, and this is a very commonly asked interview question as well, and very frequently asked as well. Okay. So here I have created a endpoint, a API endpoint. We can see over here, which is trying to just increment a counter value. Okay. Cool. Now the thing is, whenever we hit this API with, let me just show you this part as well. So this is the bash script that I have like got it from the internet, and you need to understand how this bash script is kind of working, because the only possibility that our concurrent requests are going to happen is when they are kind of given at the same time, right? So in this we have used this curl command and this ampersand, right? So this is a post request on the same API that I have written over here, and this ampersand is kind of uh, it doesn't wait for the response, so it just keeps firing that request. So that's exactly how a real world scenario will look, right? So you can assume these are like 100 concurrent requests that we are making to our API. Cool. So as it goes over here, we have a very normal counter function. So if you go to the increment counter function here, I have right now made it synchronized and everything like that, but let's remove it for now. Let's go to the console and let's try to run this command. Okay, so let's try to run this command and make it like 0. So our counter value, okay, it has inserted a counter value. So let me just drop the table. Okay, and let me run this. Once we have dropped it, let's create again and let's insert again. Okay, now if I do this, there's only one row in our database, which is, and it has just one value. For now, just look at this count value. Okay, now I'm gonna if I see in this increment function, it's not synchronized. There is no such thread safety that I have tried writing over here. So let's fire this bash script. Okay, somehow it is coming as 100. Okay, so there is some sort of some sort of concurrency handling that we have done. Okay, so let's try to find out how is this increment counter is getting 200. So first of all, let's try to confirm this. So this is 100. Okay, and I think this has to do something because in the JPA I have written a column with version, right? So let's remove this for now. Okay, we'll remove this as well, and let's go back to the console and let's drop it again. Okay, this time let's create, but let's not create the version. Okay, so we can just, or maybe we can write a different command. Okay, so I think that is fine, right? So I just need to give 1 0. So let's try to run this one. Let's try to do this. We have our counter table, and then I insert this, and then I again run this. We have, okay. Now let's again go and try to run this bash script. Okay, we have some really okay, let's try to figure out what is this issue. This is some JDBC exception execution. Okay, so this is of course because of the counter. And what is the problem here is we have this, we don't have. Okay, let's try to see this issue. So it's kind of even selecting the version, so we need to start this again. Okay, we can do that. And now let's try to go back to the script and let's try to run this. Okay, this time it ran, and let's try to see what is the value. You can see the value is 9. Okay, we fired 100 requests, but the final count value is 9, which is not how it should be, right? It is not giving us the correct value for the count. So why is this happening, right? Now, so let's try to see like what is actually happening right now. So our request goes to this endpoint, which is API/counter/increment, and it goes and it tries to increment the counter. Now at the same time, let's say if one of the count value, like let's say there are multiple requests and they are trying to enter this part of the code. Okay, and this part of the code, when the request reaches to this part of the code, right, it tries to increment this, it tries to get the get count value, and it tries to do that +1, and then it again save it to that our repository, okay, which is the same table. Okay, that's what it is doing right now. This is a very simple, you can imagine it like we are going and we are just incrementing the counter value. Now if you imagine there are two users who are getting the count value. Right now the count value is 5. This guy goes increments right 6. That guy goes increments right 6. But that's not how it should be, right? It should have somehow, we should have implemented it in such a way that when the 6 reaches, then next time the other guy comes, and then 6 to 7. Okay, that's how we are going to, that's what we are going to solve. Okay, now I'll do nothing, I'll just type synchronize. Now what does synchronize will do? Okay, now in multi-threaded program, this part of the program is called critical section of the part, where this part has high probability, or you can say this part will definitely have chances where more than one thread will try to execute this part. Now we need to make this thread safe. Okay, so that's why we have just written synchronized. Now the internals of synchronized you guys can read. This is basically like using mutex. We could have used mutex or semaphore to implement this part as well. Now let me run this again. Okay, let's go over here. Remember our counter value was 9. Now it goes and it is becoming 109. See, just by one keyword we are able to solve this issue. Okay, but here if you see in synchronized, what happens is like this whole critical section, right, is just given to one thread at a time, and other threads are in a waiting queue. Okay, so this is some sort of a pessimistic approach to solve this problem. Okay, now let's go back to what we had before. Okay, the optimistic approach. In optimistic approach also we had, okay, maybe I can go over here and let me just take everything, and this is fine, and then I go over here and I take all of this as well. Okay. So now what we do, we go to our entity counter. We have introduced a version. Okay, we have introduced a new column. Okay, version, and internally here if you see, we should, if I go to controller again, I'm not doing anything special, and now I don't think even I need to remove use the synchronized keyword here, because once we have made that version, that's what that annotation does. It will internally take care of it. Okay, but we need to understand what is actually happening. Okay, there is no definition for this, but that's what is happening. So let's try to run this again. Cool. Remember 109. Okay, we have some error, but that is fine. Oh god, I think I ran into some all requisition. We have a JDBC exception. Okay, because we did not update the table, right? We need to update the table as well. So yep, let's try to uncomment this line. Let's try to drop the table. Let's try to remove this line. Let's try to create the table, and let's try to insert this. Right, let's try to run this again. Now it starts from 0, and we go to we go and try to run the bash script. Okay, we are again facing an issue. So let's close this. Let's try to see what is the problem. Oh, we have few requests have passed. Okay, so I don't think this is the issue. So we are going increment counter. I go over here. What is the problem? We have just synchronized keyword. Okay, let's just try to take the synchronized keyword and try to run it. Okay. This ran fine. We go over here and we try to fire the request, and now this is 130. Okay. Okay, so maybe synchronized was also required there. But let's try doing one more thing. If, or maybe I did miss something. counter is fine, version is version, yeah, that is fine. So if I don't use synchronize, of course, okay, we can have multiple, but since we have created a version column, the database should take care of the versioning issue. Oh, I get it. If I remove the synchronized keyword and then I run the same thing, okay, you'll see some of the requests will not go through, right? And that's what the pessimistic locking is all about. So our counter value is increasing, but it's not increasing by 100 because not all of the 100 requests have made through the condition of the optimistic logging, and that's what happens. Now you can see here we have a message saying row was updated or deleted by another transaction. See, this is the optimistic way of solving this problem, and we are not blocking any sort of requests. Okay, we are using database update statements and with a version column to check if, let's say, okay, so what is this version column is actually doing? This version column is, let's say right now for this row, okay, let's go over here, let's go and try to run this. So 13, we knew it went to 113. Now it did not increase to 100. So out of 100 requests, okay, 113, 16 requests only made it through. Okay, so you need to understand what happened to another 84 requests, right? So another 84 requests were not able to go through because their version did not match while writing to the database. So that's what version does. So let's say right now, if the next user comes in and he tries to write it, okay, and if he tries to write it with the same version number, then this will throw an error. It has to be 130. Okay, so that's the optimistic way of solving this problem. We could have solved in various other ways as well. We could have put a constraint key and we could have written that query, and this only the thing would change was this error message. Now the error message would be like the constraint key violation. Okay, so that's one way to solve the problem. Okay, cool. What else can we talk about? Now there is one more way to solve this problem is by using an idempotent key. Okay, now what is an idempotent key is, doesn't matter how many times you send the request. Okay, if the idempotent key is same, the result returned will be always same. Okay, so to do that, I'll just try to tell you the places where our implementation will change. Okay, so here we'll take something like a idempotent key. Okay, we can take something like idempotent key from the user, and let's say we have something like a cache result. So if that cache result contains this idempotent key, okay, we'll return that result. Okay, if it and if it doesn't, then it does this thing. Okay, so that's how we can even use the idempotent key to implement this problem. Okay, cool. Thank you guys.